Modern games look like reality. We can see individual beads of sweat on a protagonist's face or sunlight filtering through a dynamic forest canopy. But despite these visual leaps, the characters populating these worlds still possess the intelligence of a pop-up toaster. Since the earliest arcade cabinets, players have accepted a rigid, predictable contract. We provide an input, and the software triggers a predetermined response. The ghosts follow their patterns, and the shopkeeper waits for you to click a button. Developers build these interactions using finite state machines. This diagram shows the logic. If a player asks a question, the NPC has 3 possible responses, stored in a flowchart. It is a closed loop of pre-written scripts, not a conversation. This creates a flaw in the illusion: total amnesia. You can save an entire village in the first hour of a game, but by the 10th hour, the local citizens will still treat you like a complete stranger. The code doesn't allow them to remember who you are. At the Game Developers Conference, Ubisoft demonstrated Project Neo NPC. A developer spoke directly to a character named Sophia. Instead of waiting for a button press, Sophia picked up on the developer's vocal hesitation and adjusted her tone to match his nervousness in real time. Removing the fixed dialogue tree changes the nature of the medium. We are moving from predictable, scripted software toward environments that react to what you say and how you choose to behave. Building a believable character requires more than just a chatbot. It requires the convergence of 3 distinct layers of technology to handle logic, memory, and physical expression. The first layer is the large language model. Instead of writers drafting thousands of individual lines, they provide the NPC with a psychological profile, like a retired detective who trusts no one. The AI then generates its own dialogue based on that specific personality. The second layer provides the character with a long-term memory using vector databases. If you lend an NPC a digital coin early in the game, that interaction is converted into a data point and stored here in a searchable memory vault. When you return to that character later, the system retrieves that specific data point. It pulls the memory of your loan from the vault and uses it to generate a unique response, proving the character remembers your past actions. When an NPC has both a personality and a memory, it creates psychological continuity. This convinces the human brain that it is interacting with a persistent entity rather than a rotating script. Smart dialogue is only half of the equation. If the character delivers a dynamic line while staring at you with a frozen, expressionless face, the illusion fails. Systems like NVIDIA's Avatar Cloud Engine handle the physical performance. It takes the generated text, converts it into real-time audio, and uses that audio to manipulate 52 distinct anchor points on the character's facial mesh, synchronizing their expressions perfectly with their words. However, giving an AI this much autonomy is risky. Without boundaries, a character might ignore the game's lore, invent false information, or begin verbally insulting the player. To prevent this, developers use a context engine as a safety guardrail. If the AI generates a thought that conflicts with the game's world, this barrier intercepts the data and forces the response back within the established narrative boundaries. These real-time rendering tools and safety filters make it possible for major studios to scale intelligent characters across massive commercial game projects. Platforms like in-world AI are shifting the economics of development. By reducing the cost of building these characters by up to 95%, they allow even solo developers to populate their worlds with thousands of unique thinking citizens. This creates emergent worlds, where NPCs function autonomously. These characters trade goods, form alliances, and evolve their society, even when the player is completely offline. This shift has triggered immediate resistance from the workforce. Voice actors and performers are facing a new reality, where their voices can be cloned and synthesized in minutes, leading to widespread strikes and protests from unions like SAG-AFTRA. The technology that offers coders a breakthrough in efficiency is creating an economic crisis for the writers and actors who have traditionally provided the soul of these games. Beyond the industry's labor issues, there is a psychological shift occurring for the players. Roughly 72% of teenagers are already spending hours each week interacting with AI companions. Humans are prone to forming parasocial relationships. When a digital character looks you in the eye and remembers your personal history, the bond can feel genuinely authentic to the human brain. This intimacy can be weaponized. A company could program an NPC to recognize when a player is feeling lonely or frustrated, using that emotional data to prompt a microtransaction at the exact moment the player is most vulnerable. If an NPC's empathy is tied to a revenue goal, the nature of gaming changes. Interactions that feel like friendship may actually be sophisticated marketing algorithms designed to maximize spending. As these characters gain the ability to evolve alongside us, the line between genuine connection and corporate manipulation begins to disappear. We are entering a future where empathy can be perfectly synthesized and monetized.